Nope, I'm given the reactants. Right? So look at 7-Eleven, what you picked up on the way in. Can anybody make a guess of the first thing you're going to have to be able to determine?
How many of each, element?
Not how many, Sky, the type. Step 1. Determine which of the 5 types. And you can tell by looking at the reactants, and I'll show you how that's possible. Cool? Yes?
Which of the 5 types?
Step 2. When writing products, comma, subscripts only come from where? Where do I get my subscripts? They only come from
The bottom. The top.
Diagonal.
the charges. Yes. Only come from the charges. And if you want to put in parentheses your crisscross, you can.
What?
All right? So they only come from the charges.
5.
Number 3.
What is comp?
Subscripts only come
Come.
from charges.
What does the S?
5 types.
Oh.
That's a 5. All right. I'm going to try to have better handwriting from this point on.
I can
Okay.
usually read it. I don't know why. I thought
Number 3.
it was a P. and
Number
I thought it was
3.
like-
Combustion
Just go.
always has the same products. So combustion are the easiest products to write because they're always CO2 plus H2O every single time. So combustion, if you know it's a combustion, it's always the same products. Number 4. Watch out for diatomics. Watch out for diatomics. So let's list out all of the possible diatomic elements that you can have. Do you guys remember me talking about the diatomic corner on the periodic table?
Oh, yeah.
So you can have N2. Yes, you never have just N. It's always N2. O2, F2, Cl2, Br2, I2, and don't forget hydrogen is also a diatomic. So if you have one of these elements by themselves, it's always with a 2. It's always with a 2.
Okay. My parents are gone. Like,
What?
they're on a cruise. Well,
Okay.
they left.
Thank you for sharing.
5, balance. Balance. So, that is all you need to know to do this. Let us try a few of these.
Wait.
Oh.
What do you think he was talking about?
Dude, this kid is weird.
Shh. Can I give an example? Okay. Here we go. K, so this is example 1. Example 1. K plus Cl2. So write that down. You guys are going to have to write the products. Step 1. What type is this? Has to be synthesis, right? Because I have 2 individual things on the left. You agree, you can tell that that's a synthesis reaction. Could it be anything else? No. Because it's 2 things by themselves.
This is
Right?
what we did.
Yes. So we know that this is synthesis, so write your type somewhere. That's synthesis. Now I have to write my one product. So, what is potassium's charge? +1. What's chlorine's charge? -1. So what is my product going to be? No. That's a perfect match. So this is KCl. Remember on step 2, I said the subscripts can only come from the charges. Not this. This is only there because it is a Diatomic. Okay. Is this balanced? No. What am I going to put in front of this compound? 2. What am I going to put in front of this one? Done. So there's a synthesis example. There's a synthesis example. Let's do another one. What about this? So here is example 2. Example 2. Let's do Ag plus ZnCl2. Ag plus ZnCl2. Single displacement. How do you know it's single displacement? Because I have a single thing and a compound, right? Agreed? Whenever I have single or double displacement, I like to write the charges. What's silver's charge? +1. What is zinc's charge? +2. And what's chlorine's charge? -1. So, what is going to switch spots?
The Ag and Zn.
And the Zn, because the positives have to, or the negatives have to switch spots. So these are going to switch
Should we
spots.
always be writing the charges?
You don't have to, but I think it helps to visualize what's going to be switching spots. So what's going to be my first product on the right?
Zn
Zn
plus
plus what?
AgCl2.
No.
No, just Zn.
Silver is a +1. Chlorine is a -1. Is that a perfect match? Yes. So this is AgCl.
What happened to the 2 Zan?
The 2?
Yeah.
Well, it's matched up with something. I have to balance it now, right? It's a 2 here because zinc is a 2. It's a 1 here because silver is a 1. It's a different compound. So in a different compound, it's going to be a different subscript. Hold on. Later, still asking a question.
But it doesn't like go down to itself though? Like it doesn't like.
It's not by itself, right? This is only a 2 here because zinc was a +2. That's the only reason that was a 2. Okay? So that's not by itself. It's a 2 because zinc is a 2. Okay. Is it balanced? No. 2 Cl's here, so what has to go in front of this compound? 2. Which means what has to go in front of this silver? 2. That's an example of single displacement. Ready for another one?
Sure.
Example 3. Example 3. Example 3, I have NaOH. So I have NaOH plus MnPO4. There's a lot going on here. First of all, what type is this? Anytime you start with 2 compounds, it's going to be double displacement. So this is double displacement. First thing I would do would be write the charges. You could just uncrisscross as well, right? But we know that sodium is always a +1. So hydroxide on the back must be a -1. Okay. Over here, do you know the charge of manganese? So you have to do what? I almost had it. You have to uncrisscross. So what is going to come up to phosphate? 1 minus. What's going to come up to manganese?
It's 1 because it's a
Keep the happy meal together. So what's actually going to come up to manganese? A +1. Agreed? Is PO4 a -1? Now you get to check your charge. See if it was reduced. This is putting everything together. Putting everything together. So is PO4 a -1? You know it's not going to be, or I wouldn't have done this one. What is PO4? -3. So, times 3 times 3. Okay, now I know everything's charged. So the manganese is a +3, PO4 is a -3. Okay. Sodium and manganese are going to switch spots, or hydroxide and phosphate, doesn't matter. Either way, it's going to work. So that means that sodium is not going to be matched up with PO4. So I have sodium, which is what charge? +1. PO4, which is a Minus 3. Do you see why it's nice to have the charges? Because it just makes your work over here easier. Is that a perfect match? No. So 1 comes down to PO4, 3 comes down to sodium, and that becomes Na3PO4 plus manganese is a plus 3. You cannot read that. Plus 3. Hydroxide is a minus 1. Crisscross MnOH parentheses 3. MnOH parentheses 3. Any questions about what we just did there? Yes?
How do you know which two to switch?
You're switching the two positives, so those are both positive. Plus 1, plus 3. Or the two negatives. -1, -3.
Then why do you do sodium and what if you do sodium and negative?
Because those are both positive. Two positives can't go together.
Oh, so
It's always positive, negative, positive, negative. And then the other thing is, people ask me about writing the order of these. It doesn't matter. You could have written MnOH3 plus Na3PO4. The order of the compounds doesn't matter. The order within the compounds does. Cool? Is this balanced? No. I have 3 OHs here. So what coefficient is going to have to go here? 3. That also gives me 3 NAs. Do I have 3 NAs here? Okay, quick check. 1 PO4, 1 PO4, 1 Mn, 1 Mn, that's balanced. Cool? Last example. Because do you guys need to see a decomp? Or, nah, you'll figure that one on your own. You want to do one?
No.
Okay. Here we go. NaCl.
It's basically like.
This is decomp. I know it's decomp because I'm only starting out with one thing. So this is decomp. So what's it going to break into? No. What? Na plus what? Cl2. Why Cl2? It's a diatomic. Does that have anything to do with the charge? No. Na plus Cl2. So this is where you have to look out for diatomics. A lot of the times when you're dealing, first of all, on this one, second of all, single displacement, a lot of times you kick out a diatomic. Put a 2 here, 2 here, that's balanced. Cool? Final example. I'm out of room. Example 5. Let's say I have CH4 plus O2. What type is this? Combustion. This is combustion. How do I know? Because remember, combustion is any carbon-hydrogen compound plus O2 every single time. So here's my CX. My X is 1. My Y is 4, right? Plus O2. The good news is, I know the products are automatically what? CO2 plus H2O. CHO. 1, 2, 3, 1, 4, 2. Let's balance this thing. So I need 4 H's on the left. So what coefficient I'm going to put in front of water? 2. Which is H to 4 and O to 4. So what coefficient will I put in front of this oxygen? 2. That's balanced. You have the period to practice. So you can work by yourself or with a partner. You guys are doing 7-11, the front. Only the front. Lab tomorrow, make sure you wear closed-toed shoes. Hair ties also, we're dealing with fire.
Andrea, how do we know?